Welcome back, Science 10s. Mr. Thompson here. Once again, we're looking at 1.4 on work and energy. So a force, it's a push or pull on an object. When a force is applied, then an object will accelerate. Acceleration is a result of an unbalanced force. And so we have what's really called Newton's second law here. An unbalanced force is the product of mass times the acceleration. If we want to determine the acceleration, then we take the ratio of the force to the mass. Now, the force due to gravity is also termed the weight of an object. The force due to gravity will depend on the mass of the object and Earth's gravitational field. Now, we studied this in the last lesson, acceleration due to gravity. Here we look at g value being 9.81 meters per second squared. Here's a couple of examples. So a force of 40 newtons is used to push a 20 kilogram cart on a frictionless surface. So friction's not an important factor here. What's the acceleration of the cart? So I'm going to use the formula up above here. I'll write it down. Now I'll substitute in what I have. 40 newtons, 20 kilograms, 2.0 meters per second squared. An unknown force is used to pull a 15 kilogram frictionless wagon. The wagon accelerates at a rate of 1.2 meters per second squared. What was the force used? Well, force is mass times acceleration. So what's the product of 15 times 1.2? Okay. So we're looking at 18 now. The product of mass times acceleration is, of course, in kilogram meters per second squared, but is more commonly expressed as a newton. Okay. And number 3, a little bit of a long problem here. I don't have much space. Let's use what I have here. A bus has a mass of 4,500 kilograms and a braking force of negative 6,000 newtons is used to stop the bus. The bus has an initial speed of 80 kilometers per hour. Now they're giving this in meters per second. In fact, it's interesting to note that there's an easy conversion between kilometers per hour and meters per second. If you want to find meters per second from kilometers per hour, so in other words, kilometers per hour, 2 meters per second, there's a rule. Okay? You divide by 3.6. Okay? And if you wanted to go in the reverse, meters per second to kilometers per hour, you multiply by 3.6. I thought I'd give you a little shortcut. So first question, what's the acceleration of the bus? So in part A, what do I have here? Well, I have a mass and I have a force. And so when I look at the idea of mass and force, I can use this formula here. And so A is going to be F over m. The force is negative 6,000 and the mass is 4,500. Calculation here. Negative 1.3. Now notice we have two significant digits here, even though this is the unrounded number. You want to use the unrounded number, but two significant digits and limits us there. So I have 1.3 repeat, which is given as essentially negative 1.3 meters per second squared. Is it slowing down? What time does it take for the bus to stop? Well, stop means that you're going to set the final velocity to be 0. Okay, so for part B, time for it to stop, final velocity is 0, initial velocity is given, I have the acceleration rate, and so the time is going to be Vf minus Vi all over A. We've used this formula a few times now. Okay, 0, subtract away, I'm going to use 22.222, and then I'm going to divide that. Now I want the unrounded number here. I don't want to limit the precision here. Okay, so maybe 4 decimal places, or you can just do 1.3 repeat. Okay. Excuse me for a second. Maybe we're a little late paying our power bill. Sorry about that. And then the calculation. I get the following, 16.6665, which would be roughly about 17 seconds. Okay? So I'm going to use 16.6665 as 17 seconds. Okay? Now in part C, what distance does a bus travel while stopping? You've seen me do this a few times before. I'm kind of running out of room, so I might just decide to try and squeak it in here. The distance should be the average velocity times the time. Now the average velocity is the initial plus final divided by 2, so the average between the two velocities. And so really it's half of that, so 0 plus, right, 22.222 divided by 2. Okay? And then multiply that by the time, which I have as 16.6665. And just a tiny bit of space here. So I'm going to take that number, I'm going to divide it by 2, and I'm going to multiply it by the answer that I have already in my display there. 185.2, so it would be really 1.9 times 10 to the second meters. Okay, I've got a few questions on the next page. I'll just stop the video right now.